Good morning. Let us continue today with the preemptive scheduling technique part 2 video. In the part 1 video, we have already seen two of the methods, that is shortest remaining time and the priority based scheduling. So these two methods we have already seen. So today in this video we will go ahead and see round robin scheduling method. This is a very popular scheduling technique used in most of the operating systems. Even in the embedded operating system, round robin technique is popularly used. So let us see what is round robin, and we'll also go ahead and see the example of round robin scheduling technique. Round robin, round robin scheduling basically ensures that equal chance is given to all the processes that are present in the ready queue. So here the preemption, since we are talking about preemptive scheduling technique, so here the preemption is based on the predefined time slot. Now predefined time slot is known as time slice. So here the time slice will be decided, and after every time slice is over, like time slice is finished up, the next process in the ready queue will be executed. So here the preemption is based on predefined time slot. Now let us say that the execution is beginning. Generally in the order, the execution from the processes that are picked from the ready queue is based on the order of arrival. So it is first come first serve basis. So the execution starts with picking up the process that has arrived first from the ready queue. Then later, as and when the time slice is over, the currently running process is preempted, and the next process in line is scheduled, or is has started executing. So this sequence is repeated until all the processes that are present in the ready queue finishes or completes its execution time. Now round robin is considered to be very similar with the non-preemptive scheduling technique called as first come first serve, FCFS technique. The only difference between FCFS and round robin is that time slice preemption, time slice based preemption is present in round robin, whereas FCFS, we have seen that FCFS, the preemption or the process which is scheduled will only be shifted to another process after completion of the execution time. Let us take an example to demonstrate how round robin or RR scheduling technique works. So the example here what we have taken has three processes with the process ID P1, P2 and P3, has an estimated completion time of 6, 4 and 2 milliseconds respectively. All the process enter the ready queue together but is in the order of P1, P2 and P3. That means we have to take the process 1, P1, as the first process that has entered into the ready queue, then P2 and then P3. We have to calculate, we are supposed to calculate the waiting time and turnaround time or TAT for all the processes. Also we have to calculate the average value. Here the time slice that needs to be considered is 2 milliseconds. So let us begin. As the question or example, I have just put the example in a table. So you can see that the process IDs are P1, P2, P3. Arrival time is 0 because they have mentioned that all the processes have arrived together. So we are considering at 0th instance P1, P2, P3 have arrived, but is in the order of P1, P2, P3. So while doing the RR scheduling, we'll consider P1 first, then P2, then P3. What about execution time? Execution time is 6, 4 and 2 milliseconds, that has been mentioned. So let us see here the time slice is very important, that the time slice is considered as 2 milliseconds. So we have to change the scheduling or execution of the process or process which is scheduled after every 2 milliseconds. So time instance, if you see the table, second table, you'll see the time instance is in the twos table, that is 0 to 4 6. So after every 2 seconds the preemption occurs. So we have time instance as 0, 2, 4, 6, and so on. So let's see at 0th instance what happened. So at 0th instance, all the three processes P1, P2, P3 is in the queue. And since we have considered that P1 is one which has come first, so P1 is scheduled. Okay, so P1 will take 2 milliseconds, because after 2 milliseconds the preemption occurs. So at the time instance 2 milliseconds, process in queue is still P1, P2, P3, but right now the process that is scheduled is P2. P1 is preempted and P2 is scheduled. Okay, now out of 6 milliseconds of P1 execution time, 2 milliseconds is over. So another 4 milliseconds of execution time for P1 process is remaining. Remember that. Now at time instance 2, P2 is scheduled. So let us see the next time instance, that is 4 time instance. So time instance 4, all the three processes are still in queue. None of them have been completed. But currently P2 is exempted or preempted and P3 is scheduled. Okay, so now P2 has completed 2 milliseconds. So total execution time for P2 is 4. Out of that, 2 milliseconds are over. So another 2 milliseconds is remaining. Okay, so or else you can remember that it is 2 milliseconds of as one burst. So P1 requires 3 bursts. Okay, 3 bursts. So P1 has to be scheduled 3 times. So you have to remember that. And P2 has 4 milliseconds as execution time. So P2 has to be scheduled twice. That is, it should have 2 bursts. Whereas P3 requires only 2 milliseconds of time. So even if it is scheduled once, it's enough. So it requires only 1 burst. Okay, so that's how you can easily calculate here. So P1, P2 at time instance 4, we have already scheduled P1, P2 and P3. So all 3 have been scheduled. Now let us see at 6th time instance. So what is going to happen? So here P3 requires only 2 milliseconds of time. That is already at 4th time instance P3 is scheduled. So it requires 2 milliseconds. So at 6th time instance P3 will complete its execution. So at 6th time instance P3 is process completed. So we have now only 2 processes in the queue, P1 and P2. So out of that, P1 is scheduled because P1 is in the first order. Okay, so 8 milliseconds P1 has completed, P1 is preempted and P2 is scheduled. So currently, what is the current status now? Current status is P2 has completed 4 milliseconds of execution time and another 2 milliseconds is remaining, and P2 has completed one burst, that is 2 milliseconds of time, and currently it is been scheduled. So at 10th time instance, what is going to happen? 2 bursts or 4 milliseconds of P2 will be completed. So P2 is completed at 10th millisecond. So 10th instance, that is the reason why only P1 is remaining in the process queue and P1 is scheduled. And by the time of 12th instance, P1 will also get completed. So you can see that when you see the process scheduled column, 3 times P1 is scheduled. So 2 milliseconds 3 bursts, 6 milliseconds is over. 2 times P2 is scheduled, so 2 milliseconds 1 burst, 2 bursts of 4 milliseconds is over. And P3 requires only 1 burst, so P3 is scheduled once. So this is how the scheduling table looks like in round robin scheduling technique. Okay, so but now the table is incomplete. We are yet to calculate the waiting time and the turnaround time. So let us see how to calculate the waiting time. So taking the reference of this table only, we are going ahead, and I have drawn a bar chart. So this is the timing chart. We also call it as a timing chart of all the processes that are scheduled. So whatever are the processes that are scheduled, same timing chart is being used here. So 0 to 2 it is P1, 2 to 4 P2, 4 to 6 P3, 6 to 8 P1 is scheduled, and 8 to 10 P2, 10 to 12 P1. So this is the time chart that we have. So this time chart will be helpful for calculating waiting period of individual processes. So let us start with the waiting period of P1. Okay, so let us see, P1 has been scheduled 3 times. So we will have 3 different time instances to calculate waiting period of P1. Okay, so first initially it was scheduled, so initially P1 need not have any waiting period. So the waiting period of P1 initially is 0. Now when has been next it has been scheduled, next it is scheduled at 6th time instance. So if you see, P1 is scheduled at 6th time instance. Okay, and it was completed previously, it had completed its execution at 2 milliseconds. So what is the waiting period? 6 minus 2 is the waiting period for second burst of P1. Okay, now what about third burst of P1? Third burst of P1 starts at 10 milliseconds. You can see that third burst of P1 starts at 10 milliseconds. So 10 milliseconds, and previous or second burst has completed at what time? 8 milliseconds. So 10 minus 8, that is 2. So the total waiting period of P1 is 6 milliseconds, correct? So that is how the calculation of waiting period goes on. So let us see even waiting period of P2. Once again, P2. So P2 has acquired 2 bursts. Okay, so we will have 2 different waiting periods. So the first instance, the P2 had started at 2 milliseconds, so it has to have a waiting period of 2 milliseconds, correct? Then next burst has started at 8 milliseconds. P2 next burst has started at 8 millisecond, and previous one was over at what? 4 milliseconds. So 8 minus 4 is the waiting period. So the total waiting period for P2 becomes 6 milliseconds. What about P3? P3 has only one burst and it started at 4 milliseconds instance. So the total waiting period is only 4 milliseconds. So average it out, average we get it as 5.33 milliseconds. What about turnaround time? Now that you have waiting period, turnaround time is very easy to calculate. That is waiting period plus total execution time is turnaround, right? So we come back to the table here. So we are seeing that P3, we have already calculated the waiting period. P3 waiting period is 4 milliseconds, P2 is 6 milliseconds, and P1 is 6 milliseconds. How do we calculate turnaround time? As I have already told you, turnaround time is nothing but waiting period plus total execution time period. So P3 has 4 plus 2, 6 milliseconds, 6 plus 4, and 6 plus 6 is for P1. So the turnaround time is 9.33 milliseconds for this example. So this is how you're going to calculate the or demonstrate the round robin scheduling technique and calculate waiting period and turnaround time. Thank you.